Hey everybody, I hope that you're doing well. So last lesson we worked on adding and subtracting polynomials. We also talked a lot about what polynomials were. This lesson we're going to just kind of step up to multiplying polynomials. Now this lesson, since we will be multiplying polynomials, that means we will be multiplying terms together. And when you multiply two terms together, that makes a new term. Because remember, multiplication holds pieces of terms together. So that means I will be able to use some of my exponent rules this time. Okay. Now the whole idea behind multiplying polynomials we've already done before. You remember how to distribute? So for instance, if I had a problem like this, you see I have something on the outside of my parentheses. Now what is understood between these two this term and this group's parentheses is a multiplication. So the idea is I have to multiply everybody on the inside by 2y. And so for instance, I'm gonna take an extra step. I know we all know that's 6xy, but we would just be multiplying 2y by 3x and then multiplying it by this minus 5. So minus 2y times 5. I know you can jump right to the answer, but I was trying to make sure you understood that I'm multiplying all these pieces by 2y. So 2 times 3 is 6, and the x times the y aren't like bases, so I can't combine them. And 2 times 5 is 10, and the y is lonely. So if you can do this, if you can distribute, today's lesson is going to be based off of this skill, okay, with some exponent rules. And we'll also combine some like terms like we did last lesson. Okay, so let's jump into examples. This is as messy as we're going to make it look. This is big and bad looking with a lot of things going on, but it's not really that hard. I just want you to first notice that over here in this polynomial, I have 3 terms. You see a term right there, right here in the middle, and 2y. So each one of these is going to be distributed to or multiplied by this term right here, minus 2xy squared. So when we do this, we just take it one at a time. I'll draw little rainbows, little arches, little arcs, so I know that I am multiplying. So let's see. And I can take my time and write this out, or we can probably kind of do this in our heads as we go one at a time. So if I multiply this term and distribute it to this first term, you notice first off the bat I have a negative 2 times a 5. Well, that makes negative 10. And I have x times x squared. Well, since I'm multiplying, remember there's no exponent showing. I could give it an exponent of 1. What do I do with these two exponents? I add them. That becomes x to the third. So an exponent rule. And y squared and y squared, that becomes y to the fourth. So we got to use our exponent rules again because we're multiplying. So here we go, we distribute it here. And a minus 2 and a minus 3, that makes a positive 6. X to the first times x squared, that is x to the third. Y squared times y to the first makes y to the third. Okay, so I've distributed it to the first. Second, I need to distribute to the third, to 2y. Let's see, negative 2 times 2 makes for negative 4. X, there's no x's over here, no like bases, so we'll just bring the x along. Y squared times y makes a y to the third. And so there, let's check to see if any of these terms are like. They are not, because they have different exponents on them. So I am finished. Now that's as big and messy as we're going to get today. We're going to do a lot of other smaller ones, but I just wanted to do a big distribute with you. So we had one term outside here, and we distributed it to 3 terms with lots of messy exponents. You can probably expect to see something like that on the test. Just let you know it's coming. They usually like to throw one like that on our test. Okay. Now other things you'll see on the test is this is a single term being distributed. What happens when I have more than one term here? So we're going to go really simple. No, not anything real messy, but you see I have 2 terms that I'm needing to distribute. Well, they usually teach this in high school as FOIL. But I hate memorizing things, center first, outside, inside, last. I usually teach it as a super distribute. Okay, super distribute. And what I mean by that is we just have two terms, everything from the first polynomial gets distributed to everything from the third. And the reason I teach it that way is if either of these grow to be bigger, like say this one's 3 terms or 4 terms, then you don't have to learn a new technique. It's still just distribute everybody. So here's how I do this super distribute. I take the first term of the first polynomial and I distribute it. X times x. Exponent rule tells me that is x squared, because remember that's an exponent of 1, exponent of 1. X times 7, that is a positive 7x. Okay, so the x has been distributed to everybody over here. Now for the 2, and I do usually show that one underneath. 2 times x is positive 2x, and 2 times 7 is positive 14. So I have super distributed. I have distributed the x, I have distributed the 2. So everybody in the front polynomial has been distributed to everybody in the back polynomial. Now it is important to look to see if you have any like terms to add or subtract. That's my only x squared, but you do see here that 7x and 2x are like. Positive 7 plus positive 2, that is positive 9x. And bring down our plus 14. So there, we have done a quote super distribute. We have multiplied these two polynomials. Okay, so let's just do lots of examples of these. They like to throw one like this on the test where they're fractions, but that really doesn't make it any harder. Having fractions actually it doesn't really change much, because when I go to do this super distribute, I go to do x times x. There's no fractions involved there. That's just x squared, right? I go to do x times a negative 5/7. Well, that's a negative 5/7 x. That was not hard, even though it was a fraction, because multiplying anything by an x, any number, you just stick it beside the x, right? A negative 2/7 times x is a negative 2/7 x. Nothing hard again. And here's the only one where you actually have to deal with a fraction. A negative 2/7 times a negative 5/7. So that's going to be a positive. Let's do some scratch work. 2/7 times 5/7. Remember, multiplying fractions is really easy. Just the tops get multiplied. 2 times 5 is 10. And the bottoms get multiplied. That makes 49. So this is 10 over 49. Piece of cake, right? Now, do I have like terms to combine? Yeah, I do. These two x's are like terms. So x squared is going to stay the same. Let's do some scratch work. You can actually take your calculator and add the coefficients here. You just have to be careful with how you type it. If you do negative 5 divided by 7, close parentheses, plus parentheses, negative 2 divided by 7, close parentheses, it will tell you that's negative 1. So these two add to negative 1x, so just negative x. Then I can bring down this fraction. So that actually isn't too nasty, even though there's fractions involved. We don't like the look of the original problem, but doing it, it's not really that bad. You do have to take your time on adding these two, but a calculator will handle this for you. And a calculator will handle the multiplication as well. You just need to include parentheses to be careful. Okay. Let's do another one. Notice I can throw more letters in there. This doesn't make it any more difficult, though. It's still the same process. 2x is going to be distributed to everybody. So 2x times 3x makes for 6x squared. If you don't know where I'm getting x squared from, it's exponent rules. X to the first times x to the first. Remember, you add exponents. 2x times 2y. Now, 2 and 2 will give us a positive 4. X and y are not like bases, so they just come along for the ride. 4xy. Look at the middle. Okay, so the 2x has been distributed to both. Let's distribute the y. So negative y times 3x. That makes for a negative 3xy. Okay. And negative y times a positive 2y makes for a negative 2. And what is y times y? Remember, the exponents are 1s, so that'll become y squared. Okay, now we're almost finished, but do you see that these are like terms in the middle? So I get 6x squared. 4xy minus 3xy, that's 4 of them minus 3 of them, leaves me with 1xy. And bring down your minus 2y squared. Okay, So this is, I'm going kind of fast, I think. I feel like I'm going fast. I may be going too slow for you. Maybe you may not agree with that statement. But I'm going kind of fast, assuming that we know our exponent rules. Now these are simple exponents because they're ones. X times x gives us an x squared. I'm just doing multiplications. If you need to write this out, what I mean by writing it out, if you need to say 2x times 3x and write out each term, you can. 2x times 2y. You do not have to show this step though. Negative y times 3x, negative y times 2y. If you need to show this out before you start doing your multiplying, you can. You will just see that 2 times 3 is 6, and x times x is x squared, 6x squared. 2 times 2 is 4, x and y stay there. Negative 3, oh, that's a times, not a, sorry, it's a little sloppy. So it's just negative 3xy. You can swatch the order. I put them in the same order. I always put them alphabetically when I have more than one letter. And y times y is y squared with a 2. So you can do that if you want to, but I'm not requiring you to show this step. You can jump right to the red step. Okay. What about one like this? Let's talk about this. So, remember we had an exponent rule for an exponent on the outside of parentheses? Well, that only applies if all the operations in here are multiplications and divisions. Because of having this plus sign right here, squaring this is not, I repeat, is not 2x squared plus 6 squared. That is not true because this plus sign messes up that exponent rule. Okay? So we are not just going to square both pieces. It's not that, I don't know the word I'm looking for. I don't want to say it's not that easy because it's not that hard either. All we have to do is go back to the definition of what it means to square something. What that tells me is it's counting how many of these grouping symbols I have. I have 2 of them. And what's inside there is 2x plus 6. So I'm multiplying 2x plus 6 times 2x plus 6. And now, even though this looks different because it's squared, this is exactly like all the other problems I'm doing. Now it's just a super distribute. And I can just go 2x times 2x, that is 4x squared. Keep distributing. 2x times a 6 is positive 12x. 6 times a 2x is positive 12x. And 6 times a 6 is positive 36. And then you're probably going to have like terms in the middle, which I do. I can bring down everything else. 4x squared. 12x plus 12x is positive 24x. And bring down your positive 36. Okay, whenever you have more than one term being distributed in your super distribute, you're going to get some like terms scattered in there. Okay. Let's see. I feel like I skipped one that I'd like to do with you. I'm not sure if they'll put this one on the test, but there is another funny instance. Let me add a page in here. There is an interesting instance where that middle term cancels out. That would be like if I have 3x plus 2 and 3x minus 2. It's when they're identical but the signs are different in between them. And so if you were to, there's no difference. You just carry out your work. 3x times 3x is 9x squared. 3x times a minus 2 is minus 6x. 2 times 3x is positive 6x. And 2 times a minus 2 is minus 4. So it works exactly the same. There's nothing different there to think about. But you notice when I go to combine these like terms, they are opposites. Minus 6x plus 6x. And so they actually add to 0 and add out. And so the middle term will drop out when you have this pattern where they're identical besides the plus and minus in the middle. Okay? So that's an interesting one. All right. So now the reason I teach it as a super distribute instead of a FOIL is because once you jump to, whoops, that's a typo. Should be a plus sign. Once you jump to more than 2 terms in each polynomial, then FOIL does not work as they've described it. But a super distribute still works. Here's what I mean. So I can distribute the 2x to all 3 terms. 2x times 2x to the second power. 2 times 2 makes a 4. X times x to the squared makes x to the third. All right, 2x to the middle term. 2x times 5x. 2 times 5 makes for a positive 10. X times x makes for an x squared. And then I got one more term. I got to distribute this to everybody. I got to distribute to the minus 3. 2x times negative 3. Well, 2 times negative 3 is negative 6. And there's an x there with that term. Okay, so the 2x has been distributed to all three. Now time for the 3. So positive 3 times 2x squared. Well, 3 times 2 makes for a positive 6 with an x squared. 3 times 5x. 3 times 5x would be positive 15x. And finally, 3 times minus 3 would be negative 9. Now, once again, whenever you do this super distribute, you're going to end up with some like terms. The more terms you have in these polynomials, the more like terms you will get. So let's go through these. I'll underline like terms. So I have 4x to the third. That is the only x to the third. 4x to the third. Now I should have 2x squared. So I have 10x squared, and I have a positive 6x squared. That will be positive 16x squared. I should have two x's. This is a minus 6x. This is a plus 15x. Let's see. Minus 6 plus 15, I believe that is minus 9x. And then finally I have a minus 9 that I will just bring on down. It's the only term. There's no like ones. So there, I have performed my super distribute. So you see that it does not matter how many terms I have. I could have 6 terms here and 100 terms here. Now, I'm not going to want to do that by hand, but, you know, you can expand this to as many terms as you want. Okay, this is as big as we make it term-wise. We won't ask you to do anything bigger than 2 terms times 3 terms. It's called a binomial times a trinomial. These polynomials have special names because if it just has 2 terms, it's called a binomial. 3 is called a trinomial. Okay. Now there's one more thing I want to show you. So remember at the end of last lesson, they snuck in some function notation questions. They do that again with this material. They want you to be able to use function notation, but they want to practice your multiplying polynomials with, sorry, excuse me, sleepy here, with function notation, with multiplying polynomials. And so they give us a function. I'll just call it g. It doesn't matter. G of x is x squared plus 6. Now, we're going to plug something in. Now, look at what we're plugging in. We're plugging in something kind of large. We're plugging in a whole polynomial into our function. That's why we like functions, because they give us the ability to plug more than just a number in. So, remember how I want you to do this. I'd like you to leave a blank where the x is, a blank set of parentheses, and copy the rest of the problem down. Because what this will enable you to do is to truly sit back and see what we have going on here. Well, let me erase my 2 and make it a little bit prettier. All right, now, what are we plugging in? We're plugging in x plus 2. So I need to be able to simplify this expression. Most of the weight of the work lays right here. We did an example where we had a squared polynomial. Remember, I have to write this out by the definition of what it means to square something. I have to expand it out in this way. X plus 2 squared means x plus 2 times x plus 2. Now don't forget to bring down the 6. A lot of people forget to bring down the number. So now I can multiply x times x is x squared. X times 2 is 2x. 2 times x is 2x. And then finally 2 times 2 is positive 4. Once again, don't forget to bring down your positive 6. So now I need to combine like terms, and I will be finished. X squared is the only squared term. You see I have plus 2x plus 2x. That makes for a positive 4x. And then finally, plus 4 plus 6. That makes for a positive 10. And so I have simplified this expression down. That is just when we take function g and plug in x plus 2. All right. So these are all the types of things you'll see on the test, okay? So you need to make sure you do practice these, because there's not a whole lot of me teaching today. I'm just working a lot of examples of these multiplications. So do make sure you understand how and where and why I'm getting at all the terms I'm getting, okay? Other than that, you guys have an awesome day, and I'll talk to you later.